Question 6. They say there's a car, he accelerates between two traffic lights. He starts here, he starts at rest, then he accelerates at 2 meters per second squared for 5 seconds. Okay, then, I did tell you that I was at a meeting yesterday, ne? Did I not? Oh, you weren't, I didn't see you yesterday. But I told you that we'll have a meeting and I'll tell you about, did I tell you? Did I not tell you? Did I give you this page? Let's start here. Did I give you this page? Okay. Those of you that are watching, you need to fetch a page. Okay. So this page here is called an ATP. ATP, Annual Teaching Plan. So this is what we are going to do this year, what counts for marks, and so forth, and so forth, and so forth. Okay, at the top it says how many practicals we're going to do, when will it count, and then you see what we plan to do in week 1, week 2, week 3, 4, 5, 6, 7, 8, 9, 10, blah, 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 until week 11. Then it tells you then week 11, you're going to write one paper of 100 marks, 2 hours, and then what you are going to write on. Okay, then you're at the bottom in the grey block. Okay, it says there the control test, it says, SPA formal. It says what we are going to do that will count for marks this year, this term. Okay, so it says there we must choose a practical, so either conservation of linear momentum, which we already did, or acceleration due to gravity, or chemistry. Okay, now my plan is to push so that we can do the chemistry practical as well, and then I can take the one in which you did better. Okay, we will see. Right, and then you must do control test. Now this is like that for the whole year. Now yesterday we had a, so you can take this, put it in your flip file. What you do with this is your situation. Now yesterday we had a long meeting on this. This is why the school ended earlier. And then they said there that when you do projectile motion, you must, so what we're busy with here, draw a diagram for yourself. Please, 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 please. They said it is not compulsory, but they said it's an absolute must that the learners must draw a picture. So when you do a calculation or when you get to a question, please, I don't just draw this picture for myself. Okay, you must draw the picture as well. Okay. So it says there, a car accelerates between two traffic lights. Sorry. It starts at rest. It accelerates at 2 meters per second squared for 5 seconds. Then, so it accelerates until a certain point, and then it starts to decelerate again. Okay, now I don't know what the velocity is here, but they say the deceleration is 4, so that is why it's negative 4. Okay, 4 meters per second squared until the final velocity is 0. Okay, so there's two scenarios. There's positive acceleration and deceleration. Okay, now in this scenario here, it accelerates until a certain point, and then it starts to decelerate. So the velocity here is the same as the velocity there. So the final velocity here is the same as the initial velocity there. I don't know what it is, x, y, z, whatever, but I know that those two will be the same. And that concept you must understand. Okay, so they ask at 6a, or 6.1, sorry. They ask, calculate the displacement for the first 5 seconds. So we are going to calculate displacement, and for that I'm going to use this formula. The initial velocity is 0 plus a half times 2 times 5 squared, and that gives you 25 meters. Right. Then they ask at question 2, the displacement for the time in which he decreased his velocity. Okay, so if I look at the second scenario, I have the acceleration is negative 4 because it decreases. The final velocity should be negative. The time, I don't know. The displacement is the question. And the initial velocity, I don't know. Alright, so I see there that I have two things that I don't have the information of, and I need at least one of them. Okay, so I'm first going to do another calculation before I can do my actual calculation. Alright, now if you look at all your formulas, your 4 formulas, each one of them needs the initial velocity. You can't do a calculation without the initial velocity. Okay, so we first need to calculate the initial velocity. What initial velocity? Sorry, I'm just going to move that there. I need the initial velocity here. Okay, before it moves. And I just said the initial velocity here is the same as the final velocity there. Okay, so I don't have enough information here to calculate the initial velocity. So I'm going to look at this scenario and go calculate the final velocity. Okay, so I'm first going to say consider the first, how many seconds was that? 5 seconds. Okay, so for that I want the final velocity. The initial velocity is 0, the time is 5 seconds, and the acceleration is 2. So that is why I'm going to use this first formula that is very easy. And that gives you 10 meters per second. So now that I know the final velocity is 10 meters per second, and that's the same as the initial velocity later on, okay, so I have now that this final velocity is the same as the initial velocity, which is 10 for there. Now I have initial velocity is 10, I don't have time, I want the displacement, I have final velocity, and. So I need a formula independent of time, and it is this formula. Okay, so final velocity is 0, initial velocity is 10, the acceleration is -4, and we want the displacement. Right, so if we calculate that, I'm just going to do that quite slow. Okay, so this is 0, this is 100, this is -8 delta x. So that becomes 8 delta x is 100, so delta x is 12.5 meters. What is wrong?
No, I was getting like 0 and 50 the whole time, so I don't know what I was doing.
Did you use this formula?
Yeah, I did, and I even got 10 as well for velocity. I think because also I was putting some, oh no, sorry, I wasn't using that formula, I was using equals to delta x.
But you don't have the time. What did you fill in for time?
I put in 5.
Yeah, see. So you didn't draw a picture and put the information where they belong. Okay. Yes, Habuki? Yes, that you got 10? 100. What did you multiply with what? Okay, where did you use the 25? Where did you get that 25 from? But you used that. Is that from A?
Yes.
A? Okay, so you put in 25. But you didn't.
This is not for.
Yeah, there we are. 2, 5. Did you square root?
Yes.
The A? No, you didn't.
I did.
No.
And I think this sounds like
100, and then you must square root it. Because it's final velocity squared. So to get final velocity, then you would have gotten 10. Alright. But yeah, so it's important that you make these mistakes now in class. Okay, and know where you make the mistakes, and we're going to practice it hopefully a million times. Not the mistakes, to get it right. Okay, then question 3. They want the distance between the 2 traffic lights. So we got the distance there to be 25 and the distance there to be 12.5. Okay, so the total distance, and I'm going to do this just here. The total distance will be thus 25 plus 12.5, and that gives you 37.5 meters. Okay, and then I'm just going to do number 4 here. They ask the average velocity with which he drove. Now, this is not question 4. Is not a question that they will ask in a test or an exam. Okay, this is just grade 10 work, so not exam. Okay, average velocity, the symbol for that is the V with a stripe at the top. Average velocity is the total distance over the total time. Okay, now the total distance that we have, we said it is 37.5, okay, from there to there. So we have the total distance, but we don't have the total time. We have the time for this is 5, but we don't have the time for that. So we first need to determine what is the time for the second one. So before I answer that, I'm going to look at the consider the deceleration. Final is initial plus a delta time. The final velocity is 0. The initial velocity, we got that to be 10 plus negative 4 times time. And we get time to be 2.5, I think 2.5 seconds. Okay, so this time here is 5 seconds and this time there is 2.5 seconds. So the total time is 7.5 seconds. Okay, so if I look at this formula again, okay, sorry for drawing so many arrows. The total displacement is 37.5 and the total time is 7.5. And I think that gives you 5 meters per second. Okay. So back to your notes. I actually want to start with this. So I'm going to do page 5. I just want to see when will the bell go. Okay, I'm going to do page 5. No, I'm not going to do page 5.